Thank you again for joining us. Our next speaker is Tali Rosman, who is the Vice President of 3D Printing at Xerox. In her role, Tali is in charge of the overall strategy, as well as the daily operations of the 3D business, from R&D to sales and customer management. Prior to Xerox, she worked at NICE and ICE, where she was the VP of Operations and Business Strategy for North America. Before NICE, Tali held roles at Stratasys, a leader in 3D printing across strategy, corporate development, and product. Tali is passionate about bringing new solutions to market and harnessing Xerox's technologies to help manufacturers build intelligent, resilient supply chains. And with that, I will hand it over to you.
All right, thank you, Amy. Appreciate the introduction, and thank you for all the interesting sessions thus far today. Happy to be here with everybody and share a bit of what we're up to in Xerox 3D printing. I don't know if you guys have actually seen the news. We announced our 2020 earnings the other day, and we were talking about our newly launched 3D printer based on liquid metal technology, aka LMX. So I'm going to talk a bit about that today and why we're doing what we're doing, and then happy to take questions at the end. So the reason we're doing what we're doing is supply chain resiliency. And manufacturers today, obviously have a lot of operational risk in their supply chain, basically in getting the parts that they need when they need it. I think, COVID really, hit that point when a lot of companies, I think it was 80% in a recent survey, struggled to get parts. And I think what was more interesting in that survey is that 50% of the companies didn't have a backup plan for their physical supply chain. Now, I spent, a few years in the software industry where 100% of the companies have a business continuity, disaster recovery plans. And knowing that 50% of the companies don't have that on the physical supply chain was pretty shocking. And I think it's especially shocking because 3D printing has a great role to play in this. 3D printing, can really, with its distributed manufacturing nature, with direct manufacturing, no need for the toolings and the mold, can really help solve that point. And that's what we had in mind in Xerox with the liquid metal technology. How do we do a robust technology that's easy to use and easy to implement and produces high quality parts that you can rely on, whether if it's your default form of manufacturing or whether you're just using it as a backup generator for when you are having issues with your supply chain. So the liquid metal system is actually based off of the acquisition of Vader Systems that Xerox did just over 2 years ago. And I'm a little biased because I'm coming from Stratasys, but to me, this very much reminds me of kind of an FFF system or FDM systems, where basically you take a spool of wire. In our case, it's aluminum. You load it, you put it in the crucible, and then you melt it and drop it, drop by drop, layer by layer, to build the parts. And maybe instead of talking about it, there's a 1-minute video that just might be easier to show you. So again, we built this production grade in mind, have the reliability, repeatability, and quality that you can rely on for your supply chain. We take off the shelf, it's non-proprietary metal wire, which is, a very good differentiator. We load the wire, and then the wire is fed into the reservoir, which is heated, and then basically the metal wire is melted, and then we eject it drop by drop, building the part layer by layer. And to ensure a lot of it, we've also wrapped it with pretty advanced software capabilities, a lot of which are coming from PARC, from the Palo Alto Research Center. And we'll talk about kind of the minimal post-processing as well and how we can get to it. Because I think this is one of those points, one of those big pain points in 3D printing that, is in the back of everybody's minds. And we've kind of tried to address it heads on. So as I was saying, our biggest thing is that the liquid metal printer uses wire over powders. So in metal 3D printing market today, As you guys know, over 80% of the market, the vast majority of it, is dominated by powder-based printers, which have a lot of advantages, but also have a lot of challenges that are preventing wider adoption. And for us, cracking the code on how to use wire instead, first of all, the most obvious thing is, material cost. Because it's non-proprietary, off the shelf, it's much more cost effective. Because it's non-proprietary, off the shelf, standard wire, we also get kind of the real known properties. And actually, we get really good material properties. When you look at our strength, when you look at the elongation and break and the density, we're able to get to really good properties. Cycle time is much faster. One of the more cumbersome, painful steps in powder bed fusion is powder removal. So with our solution, you don't need it. It's much easier and faster, and therefore, again, cost effective. But I think for me, the most exciting point is the safety. So you don't need any special facility modifications or any ongoing overheads with regards to PPE or powder management or so forth. To give an anecdote, one of the customers we talked to a few weeks ago, they were contemplating acquiring a powder bed printer for $700,000. And then the facility modifications that they would need to do to accommodate for that printer, and that's just a one-off, were estimated at $900,000. So $700,000 printer, and then you need $900,000 in facility modification, not to mention all the ongoing overheads and safety concerns. Now, when you think about using 3D printing to build supply chain resiliency, you really want to enable distributed manufacturing. The whole big vision of the microfactory, printing parts on demand closer to the point of consumption. I think powder-based printers don't really lend themselves to that, right? Because if you need to do very costly facility modifications, and again, all the ongoing risks and risk management of the powders, you're probably not going to do it in 10 different locations in your East Coast and Midwest and West Coast and the South and so on and so forth. And with our technology, with the wire-based technology, I think it's the first time in metal 3D printing that we're seeing a technology that lends itself to distributed manufacturing because it's so easy to implement and you don't need any special modifications and the training is much easier. And if these weren't COVID days, I would invite you all to see it in our facility in Webster, New York, where it's, sitting there on the production floor without any special needs. So I think that kind of gives us a unique value proposition with regards to the printer. Now, I mentioned this is based off the Vader Systems acquisition 2 years ago, but it's also important for me to stress that we've made very significant strides in the last 2 years since the acquisition. So if anybody has seen parts from the Vader printer, 2-3 years ago in FormNext or Rapid, back when we still went to conferences, I think you'd be pretty shocked at the level of progression that Xerox has made in the last 2 years. I think this is when kind of the Vader acquisition, the combination of the Vader technology with the Xerox capability really became interesting because Xerox has a lot of experience in jetting physics, in system design, in making business critical equipment that needs to be reliable and repeatable. And we kind of took all these capabilities, all this knowledge, and put it on to the very interesting Vader technology of liquid metal to make it, a production grade system. And in the process, obviously hundreds of inventions to get us to the part quality and the printer quality that we're in today. So one of the things we had in mind, I was talking a lot about the technology benefits and how it lends itself to distributed manufacturing. So I think if you want to lend yourself to distributed manufacturing, you have to be much easier to use and easier to operate. So I want to give you kind of one example in mind when we're talking about that. And this is the part removal process. So obviously this is filmed on an R&D rig in a lab. That's why it's kind of open. If we'd done it on kind of the real printer and not an R&D rig, we wouldn't have been able to get, these beauty shots. But here again, you can see how it works. But I think the really cool thing is the part removal off the build plate. If you're familiar with a lot of 3D printing technologies, you have to saw off the part off the build plate. And again, that's cumbersome, doesn't lend, it's not really scalable. With ours, and this is real time, literally takes 5 seconds in a bucket of room temperature water, and within 5 seconds, that part's been removed off the build plate. And I think, really the cool thing is, and you're seeing it here, I ran too fast, is the part quality as it comes off the printer. So, we get to really good part quality. I'd call it kind of sand casting or better, surface finish. And again, much easier removal. And in all these things, it doesn't translate just to ease of use. It translates into money, right? Everything translates into money. The more time you have highly paid, specialized engineers working on it to get the part off the build plate, that's time that you're not getting the part yet, and that's money that all this is costing you. And so with that, and Xerox, we're big believers in what we call eating our own dog food. And by eating our own dog food means we're gonna walk the talk and we're gonna implement our solutions for ourselves. So we basically trained our engineering teams, we educated them that, hey, we have this solution, these are the capabilities, these are the parts that you can make with it. Next time you have an issue with a part in the supply chain, let us know. Let's check it out. Maybe we can help. And so as we educated the engineers, we started getting parts that we were having issues with, again, especially in 2020. And we said, let's see what we can do. And actually quite a few parts we can do with our printer in a cost-effective way for Xerox. And this is one example. This is a bracket for an iGen 5. So an iGen 5 is kind of a high-end digital press on the 2D side of Xerox. We want this up and running constantly at customer sites because for every day that this printer sits idly by and is not printing pages, we lose, up to thousands of dollars in potential revenues. So when we don't have that bracket, we're losing a lot of money. Our interest is get it as fast as possible in the customer's hands to get the printer back up and running. Because the iGen 5 is more than 15 years old, its legacy, it's low volume, and basically the supplier about 6 months ago, I think, told us they will no longer be supplying this bracket. And so the team came to us, and very fortunately, we were able to print it. This says 4.5 hours. Actually, we've improved significantly since then. We're much faster. But as the team was facing an option of, okay, let's go out, find a new supplier, which will take weeks. Qualify that supplier, set them up, which will take more weeks. Do the tooling all over again, which can take months. And all that while, we can be stuck. Or let's go to the 3D printing team, and in 4.5 hours, we can get that bracket and install it on the iGen 5 and get it back up and running. So, we're absolutely eating our own dog food. And in eating our own dog food, we're not just thinking about the quality and whether it'll work, it also has to make economic sense. Okay, I can assure you the iGen 5 team isn't cutting me any slack or giving me any benefits just because I'm also part of Xerox. They're thinking about their own P&L and the cost. And so we had to show them not only does this work from a part quality perspective, but it also makes business sense for you to do it. And as we analyzed it with them, we looked at the true total cost of ownership. So a lot of companies and a lot of the customers we're talking to, they just compare the green bars, the unit manufacturing cost. How much does it cost me to get it from the supplier who does it with metal casting versus what is the cost to 3D print it on the liquid metal printer? And what they're ignoring is the blue and the orange bars, which can be very, very large. And these represent things like, with that supplier of the bracket, you can't just buy it on demand for metal casting. You have minimum order quantities. And it could be that the minimum order quantity is 1,000 units. But I was saying the iGen 5 is 15 years old. We don't need that many. So you're putting upfront cash on things you don't need. And then you have to store them. So you have your inventory, warehousing cost. And then you're going to have to scrap some of them because you probably don't need the whole 1,000 because it's a low volume spare part. So you paid for nothing and you accrued the inventory cost, and now you have the obsolescence and the scrap cost. So we quantified all these things, and actually we've developed some pretty nice, advanced tools for our internal use to give true estimates to management and to the business side to make informed decisions. And I can tell you with this specific bracket as an example, we showed that we can yield by incorporating 3D printing into the supply chain, we can reduce the cost for Xerox by 21% when you factor all this in. Anyone in supply chain will tell you reducing the cost for a part by 21% off the gate is remarkable. These are really good numbers. By the way, as a side comment, not only can we reduce the cost by 21%, actually by incorporating 3D printing here, we're also reducing the carbon emissions by 43%. So a lot of companies, Xerox included, are very much committed to taking a hard look at how we can reduce carbon footprint. And for this specific bracket, by incorporating our printer versus metal casting, which is what was used up until now, 43%, which is fantastic. But the team made us sweat even more because they said, okay, let's not just compare you to metal casting. Why should we pick your 3D printer? Let's compare it to others as well. So we wanted to get an external analysis to have it unbiased. We worked with the Barnes Group, which I'm sure many of you are familiar with. And the Barnes Group benchmarked us against other technologies, traditional and 3D printing. I'm showing here powder bed fusion comparison because, as I was saying, powder bed fusion is over 80% of the metal market. So while I don't think we're in competition with powder bed fusion, I think we're complementary technologies. I realize this is what we're most often going to be benchmarked against. So this is an example. And here we're up close to 40% cheaper. And by the way, 40% faster on the cycle time. So faster and cheaper and good quality. And again, all this has been done for us by the Barnes Group. And so I touched on kind of powder bed fusion and why I think we're not competing, we're complementary. And to elaborate a little on this point, this is kind of the good, the bad, and the ugly of us and powder bed fusion. So the first advantage we're seeing for us is kind of the deposition rate versus equipment price. So to explain this in a second, it's really hard to look at list prices because you can compare yourself to an entry level or a medium or very high throughput printers. So what we did is we basically took kind of the list price versus the throughput. So how much throughput do you get per dollar? And we compare throughput per dollar, we come on top. Cycle time, as I was saying, we also come on top. We actually get really good warpage. Post-processing time, part removal. Again, all these things kind of go hand in hand, right? Being Xerox, we have a mindset of you need to make it easy for the customer. It needs to be easy. It needs to have a great customer experience. So that's what we're constantly working on. And part of that is to make it less cumbersome, less labor intensive, simpler part removal from the plate, no powder removal. All these things we think are very important. Infrastructure cost and safety also go hand in hand, right? You don't need to do all these costly facility modifications. You don't have the safety concerns that cost you a lot of money on an ongoing basis. And one last point is material waste. So actually we visited a customer earlier this week and they told us that in powder bed fusion, 35% of the material is wasted. You can't reuse the powder if you're going to make real parts. So, for every $100, $35 goes to the garbage. So that's a great advantage that we have. However, I was saying we're complementary because if you want to make really complex parts with very fine feature resolution, you're probably going to opt for powder bed fusion. So I think that's kind of where I'm seeing this. I think all these technologies have room to play together side by side. And obviously powder bed fusion has been around, for quite some time. So in terms of the material breadth, they offer a wider range than our current system. Although I will say, as you can imagine, we are working on expanding our material range. So just to recap and then open it up for questions, we built this being production grade in mind, something you can rely on for your supply chain resiliency, right? If you're going to need a backup generator, that backup generator should work when you need it. We really thought about how to make it easy so it can lend itself to distributed manufacturing and create a seamless, easy customer experience. And again, this all ties into us being Xerox, and we understand what that means to be that trusted partner, to meet those business critical SLAs. And so, if you want to follow up, feel free. And hopefully there's some questions coming in the chat as well.
Sorry, it took me a minute to pull up. Thank you so much. That was a great. We have lots of questions. The first one is, does this only work for aluminum? What other materials can you process?
Oh, great question. So what we launched to the market at the end of the year, indeed, we're currently using aluminum 4008, which has very similar properties to 356 casting alloy. We're going to be expanding the range of materials with additional aluminum alloys to start, and then potentially non-aluminums down the road. But right now, that's correct.
Do you have fatigue data on the parts?
Yes, I do. You have my email there, and I'm happy to take it offline and share some of the material properties we're getting to.
I assume this is good for one at a time, like a single part. Could you do a mass number of parts at a time?
Yeah, I mean, we're limited kind of by the tray size, which is 300 by 300 by kind of 120 on the Z. So to the extent that you can fill that tray.
All right, I know that. What's your minimum feature size?
Oh, wow, we're going deep here. All right, I like it. Yeah, so I'll pull it up in just a second. Sorry about that. What's the next question in the meantime?
Yes, what are your target markets and applications?
Great question. So right now, because of kind of our material choice, I think this kind of really lends itself to aerospace, defense, automotive, heavy equipment manufacturers. In fact, again, yesterday we actually announced in our earnings call that we've partnered up with the Naval Postgraduate School. So they actually got our first printer in early December, and they've been using it for 2 months, and we're exploring additional use cases for the Navy together.
Great. Let's see. What is the overall smallest size part you were able to print?
Yeah, so hold on, I'm pulling everything up right now, but so first of all, our minimum layer thickness is 240 microns. And then in terms of the dimensional accuracy, it's 0.2 millimeters on the X and the Y and 0.3 on the Z. And again, I'm kind of, we have all the specs and material properties and whatnot. Everybody can feel free to, reach out to me on LinkedIn or in an email, for kind of the specific properties and such. We're happy to share those offline.
Great. Do you have an idea of what your minimum order quantity might be in the future?
Well, if you can pay for it, I'm happy to sell as much as you want.
Good answer.
Yeah, happy to. As many as you want. Please.
There you go. There's a lot of detailed questions here. What is the print rate currently? I don't know that. I don't remember you saying what the output was.
Yeah, so we get to up to 0.5 pound an hour. As you guys know, obviously, if you do kind of sharp corners, you have to slow the speed down, but we get up to half a pound an hour.
Great. What is the upper limit to this, I guess, to this deposition rate?
So the maximum deposition rate is half a pound an hour right now. Again, we're in continuous improvements mode, but right now we're at half a pound an hour.
Oh, sorry. I think maybe that was more like the physical limit, but it probably has to do with your resolution. But we'll just skip that question. Let's see. Do you have a presence in Canada?
Yes. I think, this is, again, one of the really great things about being part of Xerox is, Xerox has global coverage from, sales, customer service. I think we have customer service people in 140 some countries. So yeah, so we're definitely can go global.
I think you mentioned build size before. You said it was 300 by 300.
Yeah, so it's 300 by 300 on the X and the Y, and 120 on the Z.
Great. All right, 2 more questions. Are you able to disclose what supplier you are using for your aluminum? And you're using wire, right? Not copper. So
yeah, so it's a great question. So again, it's non-proprietary. This isn't something that was uniquely developed for Xerox or anything of that sort. And we are working basically with a material supplier who's providing us the wire.
Okay, and so this last question is, what is the international availability of your materials? I assume that means your products.
Yeah, so again, this is the really great part about being part of Xerox. We have presence in so many countries, from sales to customer support, logistics. We're basically global, so you can buy as many as you want, where you want.
All right, well, thank you so much. That'll give us a couple minutes break before the panel that's coming up. But I just want to thank you. Such an interesting technology. I think we're all just really glad that you were able to present this to us today. So thank you.
No, thank you guys for the opportunity. It's been a pleasure, and I'm looking forward to the rest of the sessions today and tomorrow.
All right, thank you. Yeah.
Bye.